Yep. So what did you do from where we left off yesterday?
Oh, me.
Yeah.
I did those things over and
Uh,
over again 9 times.
Yeah.
did you do okay? What's with the condition at the end? So you're saying if board 00 is the same as board 01 is the same as
Port 02, but not the same as that dash that is in the board.
I see what you're saying. Okay. Okay. Oh, you did it the other way and then you found out there was bugs.
Yeah. Without
Eh,
the dash, you play once and then it came out and said, what
the
is it?
winner is
Dash
dash.
winner. Yeah.
Can you scroll up to from yesterday? When I say,
Yesterday we only did this part, isn't it?
yeah, that one. I'm trying to catch up to speed with that property. For A and range, marker equals else marker equals play board, and then winner equals winning board. Winner.
I have a once you're ready, Nkosinati, I have an ask. Can you just zoom in a bit, like twice, maybe? So just press, yeah, you know what to do, miss. Yeah, no, once is fine, I guess. Once is fine. Cool. I know, just one from here.
What do you mean one from here?
Like zoom up one from here. Alright, cool. Yeah. Goes net.
Yeah.
Are you ready or not to oh you waiting for something?
I'm not sure what you're asking me.
Because you asked them to do something on the code and then you didn't respond. So I don't know if you're looking at it, writing it down, or doing something else.
Yeah, I'm writing it down.
Okay.
Speak while you're at it.
Cool. So yeah, just go down to the last one. Yeah. So I have an ask, right? Mr. Jack.
Mhm.
So how do you know like actually just I just want you to you see the bot you have at the bottom there?
Mhm.
Uh the one that you can see in your console with the X at the top. You see that, right?
Mhm.
Player none has won. So actually run your code now. Does it work now?
Yeah.
Save. You didn't save though. Save it. Let's see.
It runs a bit. What the hell? Oh, what the hell?
Click on the terminal, bro. Yeah. Cool. Go ahead. Okay, cool. So what I want you to do, right? I want to ask you something. Actually, before I ask you to do something, what is for number one, right? Like you see where this little board here where it says play X1 just on top.
This.
Yeah, that. So you have those three X's in a row, right? So I'm actually before I do that, I'm gonna open up my side so I can just show you guys something quickly. I'm just gonna share my screen. You can stop sharing your screen. I just want to show you something that you can use. I'm not going to tell you what to do. I just want you to see something. And then I'm gonna present now. Cool. Can y'all see my screen? So, cool. Yeah. Can you put in your earphones?
Yeah.
What was that?
That was what?
Someone did he send? Someone send a message. Can no one send? Okay. Gosnat, you still there?
Yeah.
All right, safe. So we have this, right? 1, 2, 3. Just going to try and we looked at something similar before. Remember when we looked at something like this? This is essentially the structure of our tic-tac-toe board, right?
Yeah.
Yeah. So now, how would let's say I wanted to print the rows, what would I do? I wanted to print each row, like I want to print 1, 2, 3, right? 4, 5, 6, 8, 7. What would, if I wanted to print this, what would I do? What would I do? How would I write my code to print that out?
You can do a for loop and then print.
So my for loop is I'm going to say for, and then?
I in matrix.
So for, like, we're looking at rows, right?
Yeah.
Yeah, matrix, and then?
Print row.
I wanted, okay, fine, I can print my row. Let's see, that's what we want, sharp. Right? Then now if I go Python, cool, we have that. We've printed all of that in our, all of the lists inside our rows. Yeah, inside our matrix, right? So now if I wanted to look at the rows, the elements in the row, what would I do? So let's say I want to compare the elements in my row. So you know that for your first run, your row will be something like this, right? Right?
Mm-hmm.
So if I wanted to print out each element in the row one by one, what would I do?
You do the second loop.
Okay,
For loop.
for x in row, right?
Mm-hmm.
And then I can print out I can print out the x, right?
Mm-hmm.
Cool. And then we're printing everything 1, 2, 3, 4, whatever, right?
Mm-hmm.
So if I wanted to print them out by the column, right? Like now I'm saying 1, 2, 3, and then I'm saying 4, 5, 6, and then I'm saying 7, 8, 9. But what if I wanted to print out 1, 2, 1, 4, 7, 2, 5, 8, or 3, 6, 9? How would I do that?
You showed us. It wasn't long ago that we did that.
The zip
What?
method.
It was the zip. Yeah.
The one I was just asking about.
Why would I use the zip method?
Because it joins the ones in the same, like with the same index, doesn't it?
So tell me what to do. So I'll write another one here. Tell me what to do, and then I'll do it. What should I do? To print out 1, 4, 7, 2, 5, 8, and 3, 6, 9.
For column and matrix,
Okay, for
print
yeah.
zip row. My goodness, now we have to define a row first.
Yeah, so first of all, this is not a column. This wouldn't be a column in your matrix, right? Because it would be it's essentially so it finds the first one and the second one and then the third one. This is still your row, right? Yeah. You're still dealing with your row.
I think do matrix 2 before you do the for loop, and
Huh?
then you zip. Do
Sorry?
matrix 2. Ne?
Matrix 2. What do you mean?
Before you do for loop, redefine
Okay.
the matrix and you
Matrix
zip
Matrix 2. Yeah.
is
And then
equals to
yeah.
matrix.zip.
But what are you you zip two things, right?
You can zip 3.
I mean, yeah, more than one thing, yes. And zip 3. Yeah. So zip this and what?
Wouldn't then that give us matrix 2 being matrix that forms in by those columns? Print it out. Let me see what comes out.
You wanna see what comes out here?
Yeah.
I'm just gonna put a pass here.
Then comment out the first one, yo. Gonna give us a million lines, yeah.
Let's see. But yeah, this will just give us a zip object, actually. I'm gonna do that. Yep, there.
Oh.
Yeah, you literally just have your rows within a tuple. So it didn't actually zip anything. It's just one thing, right? So this doesn't help you.
Then I don't know. Wait, level. What is that method you gave us that joins the same things that from the same index?
That's the one.
This is the one.
Yeah, but it puts them in a tuple. Can't you? What's the word? Cast
Enumerate.
Can't you cast it?
You want to enumerate the other one. Is that what you want? That.
No, my issue just now was like it's in a tuple, right?
Yeah.
It's like there's a list within a tuple.
Yeah, but why would we
That
use
is,
that?
it's
Like
complicating
we
thing.
remove the zip, right? We're not using it because we know it's not gonna help us.
Yeah. Now I'm
Yeah.
trying to understand why it doesn't work or how it
Oh.
could be fixed.
Yeah, like simple answers by not using it in the first place.
Nah, because it's structured the way I want it to be structured. And I wanted to ask about this yesterday, but I missed so many bits of the class that I wasn't sure if I was asking the right thing.
Mm,
Because even in my notes of how I was gonna approach this is what how I was gonna find the columns.
yeah, I hear you.
Yeah. Okay, continue.
Yeah, so I'm saying, right here, I thought Jack was saying we should use the numerate, so that's why I was like, I wrote it down. And how is that gonna help?
Wait, enumerate, isn't it gonna just separate the nested list?
Yeah, into an I and a row. I thought that's what you wanted. That's why I did it. If that's not, then we can still do that.
Oh wait, you're giving us the answer, must do that. S- oh, well, I don't know how to go on. Hmm. Wait,
Let me do this. So one thing that you should think about, right? We when we want to print 147, 258, and 369, right? What we are doing is so we are fixing a column, right? And then moving through the rows, if you get what I mean, right? So we're going to find the first column, right? The first column is so what's the number of the columns that you have?
Zero one.
sorry.
Sorry? So it's yeah, so size your columns would be something like equals to so if I say the length of your row would be the number of columns that you have, right?
Yeah.
Cool. Now, if we fixed so what do we want to fix now? We want to fix the column. And then after fixing the column, we move through the rows, right?
Okay, I get it. I get it.
Yeah. So we have the size of our not sure if we need that though at the moment. We'll see if we need it. I'm just going to leave it at that, right? We have our row in our matrix and we want to we know that this is the number of columns, so we can say cols equals to that, right? Right? Which is the same as actually maybe if I did for call in no in row, right? That is our column. But here we inside this loop here, we're actually not fixing our we're actually moving within the elements of the row, which means we're moving through the column, meaning we are not fixing our column, right?
Yeah.
Yeah. So how would we fix our column?
Mm. Where you rumirate, man?
Okay.
Because this
Yeah.
tells me that. How does this thing work again? I'm in the
This thing will give you the index of your row.
it doesn't give me the element within.
I mean, you could do something like so we have our I, which is fixed, right? And then we want to move through what? Through our rows, right?
Okay.
So because this is row one, this is row two, and that. So let me show you something else. It's you can have for j comma call and wait row. But anyway, we actually don't need. I'm gonna do this. I'm gonna do it the simplest way. I didn't want to do that, but I'm gonna do it. Shit, I'm just gonna leave it anyway. It's fine. And then this won't work all the time, but it'll work now. Uh, 147 258 369, which is fine. Tell me if you understand what I did.
For the first row, first column, went through the row. Ah,
So, what does this give us? I want to know. What does this give us? Hmm?
It's going to give us, what is it? The value at the index j.
So this gives us the row J, right? That's what it gives us, right? Right?
okay.
And so since we're changing our our J is changing within this inner loop, right? And so here we're essentially just changing the rows with J, right? And then I is essentially fixed because I is the one at the top. Meaning when you first start, it will be zero, I will be zero for all the J's, right? And your J's are essentially your rows, right? So your I will be fixed for the first time. Your I is zero. That means you're here, right? On this row. Your J is zero. You're in this row, right? And then your I is what? Is zero. So that means you get that element, right? And then your J changes. Your J changes to one. When J changes to one, you change what? Your row, right? When you change your row, you get there, right? But what's your I? Your I is still zero. Then you go there. Hey, then you go there, right? right?
Mm-hmm.
And then you change, J changes again to a different row, and then you go there. But what's your I? Your I is still 0. That means you go there. So then we printed that. This is basically like transposing your matrix, right? So instead of, that I and J are, so normally when we index our matrix, we go IJ, right? I we go IJ because of our loop, right? And now this moves, so you're moving by the row. When you do this, you're moving by the row, right? But when we do that, JI, we're moving by the column. So remember from maths, when we did matrices and transposing your matrices, you just swap your I and your J, and then yeah, you swap your I's and your J's. Remember?
Mm-hmm.
Yeah. Huh?
I don't.
So essentially that's essentially what we're doing here.
Okay, I'm trying to use basic human logic.
Human
So
logic.
for I in row, enumerate the matrix.
Yeah.
So we're gonna fix I, and we're gonna jump through the different rows of the matrix.
Yes.
And then for J in column, enumerate row. So every
This
time,
is this is bad because I wasn't supposed to use enumerate here. I was just supposed to use because I could just, I don't need the row and and the thing in these cases. I could just use range here. Range. So now I'll just do that. It's essentially the same thing. That's what it should be,
no,
right?
I just wanted to understand what we're doing
Okay. Let me copy this.
better or what's.
Just go back to what we had. But yeah.
So for I and row, we're jumping through rows, we're fixing the column. And then whenever we are, eh,
Let's start
before I
by this.
understand line 7,
Huh?
explain line 7.
Let's
That's what
let's
I'm saying. Let's avoid, maybe let's try avoid this guy.
Just
L-
explain it.
line
let's
7.
let's
Because line 7, it's like you're taking each row you have and you're taking the elements of it. That's why I'm saying let's not look at this one because I just didn't want to change it then. But the correct way to look at it is this way, right? Because you're saying for I in range 3, because we have 3 columns, and for J in range 3, and we have three rows and 3 columns, right? And we know that this is actually our row, right? Right. Row J. So you want me to say, I'll call this row J, right? This is row J. And so at row J, we want this thing. Are you complaining? I'll call it row J. Like that. Right? Uh uh call J. Whatever. Bad naming. I don't want to name it. I'll just print it out. So this is row J, right? This guy. Do we agree with that? Because we're essentially saying in the matrix, go get, we know like when our matrix at J, it's a row, right? We're taking the row at this particular spot here. I'm just going to copy that down here. So like when we start, right, within the inner loop, right, we have I being 0, right? J being 0, sorry, right? And we're saying go to the matrix and get the row at 0. And the row at 0 is what? Is this guy, right? And then from that row J, we want to go and get value at I within that row. So we're saying that in row J, go get the value at I. So now I to start off with is 0. So that means when we start, we have J being 0 and I being 0, meaning we get the value 1, right? And then we print out 1. But then we're still running within the inner loop. So when that changes, J changes, right? That means J changes to what? To 1. And then now we're looking at row 1. And now what is row 1? Row 1 is this guy, right? And then in there, we are still looking at column I, which is 0 because we're still within the inner loop. And then what do we look at? 4, right? So we're basically going to go look there, and then look there. And then when we come back, we're going to look there, and then look there. And then the last time we look at that, and then look at that.
Oh, I think it starts to make sense.
Yeah, the middle line is the confusing one.
Which one?
Like just what I complained about before, it was like now it's 12. Yeah, understanding that was
Mm,
what was hard. It's like we're starting and we're saying within the row, give me first index, and
yeah.
then
Because
after
I
that,
think I know what you wanted to do initially, right? With the zip. You wanted to go do
I
something like,
was supposed to transpose it.
yeah. So let me show you something. I think it's gonna work. Uh print list of I'm gonna do that. Uh, wait. Uh, uh, hey, yeah. Come on now. So you see that? That's what you wanted to do, right? Yeah. I mean, you essentially just made the columns there what you wanted. So that means now to print it out, you just say uh you do something like for call in uh in that guy print, what do you want to print? Then, well, it's essentially the same thing we had here, but we zipped it, so we actually just have our columns. We have our columns there, right? So do you know why I'm showing you guys this? Actually, do you understand why I'm trying to show you this?
Which part?
All of this that we're doing here, like navigating through our rows and navigating our columns and all of that.
I guess it will help if you're trying to capture data and then
So
group
it's
it.
because like what Jack has in his code, right? On the tic-tac-toe game, he's doing everything manually, but you don't have to, right?
Yeah, yeah.
So if you're looking at your rows, and you say, okay, if now you want to check, you just want to check if the whole row is the same thing, right? Like now let me show you something here. I'll make this 1 1 1 1, right? So we know that the second row everything is the same, right? Meaning in our tic-tac-toe game, you'd have something like one. Actually, I'm gonna do this. Right? We have that. And then we want to compare. So I'm just gonna create a new
Who wins in that auction game?
huh?
There's two winners. Oh no, it's the same one. Wins twice.
Is it
Make that last one a 0.
where's two winners?
No, I'm being pedantic, but it's okay. Continue.
It's whatever, like it's whatever it is, we'll find it, right? So now we have, if I want to compare my row values and find out if there's a winner within the rows, right? I'll say for row in matrix, right? And then now I want to compare each values within the row. So I know that that's my column values for call in row, right? And then I'm comparing those. And then, but what I need to do now, I need to compare a previous value to the current value, right? So I can go current equals to here I can say row at 0, and here I know I'm going from 1 to the end, right? Are we good? Is that understood or not? So if current, no, previous, this is previous. Yes, current, right? If current is the same as previous, right? The current is the same as previous. Actually, if it's not the same, then you want to break, right? Right? No feedback.
I
Huh?
understand that. Yeah. I got
Yeah. And then if it was, if we do finish our loop, right? If we do finish our loop, that means all the, actually no, we're missing something here. We need to do that previous equals to current, right? So that we swap it out, right? We don't even have to swap it out, actually. Yeah, we don't have to. We don't have to. But either way, it doesn't matter. This doesn't matter. So, but if we do, then we can return our,
value.
actually, wait. What are we doing here? We're comparing values in the rows, right? So return, here we return, right? And here we return previous. What's going on? What's going on? Remove return. I'm gonna do this. Return none. Why is it saying this? Oh shit. Because I don't have in this function, right? What's this? Def compare row And we have that, right? Cool, right? So I don't have to do that. So if we get here, that means we can, do I want to break or do I want to return? I actually want to break, right? Actually want to break.
Yeah,
Yeah.
that makes no sense.
Because I want to know, okay, this row is not, so then now we want to move on to the next row, right? We'll move on to the next row and check if that row is has winning things. Otherwise, if we don't, so if we break here, we'll never get here because it'll go there. Yeah, we'll never get here if we always break, right? And if we do get here, it means we found a winner. So now I'll show you something. Let's just run this on. So we're gonna run this on. I'm gonna actually make this. I'm gonna call this data here. Data. I'm gonna call this matrix so that we can give it a matrix layer. And then I'm going to run this on our data, right? And then just print that out and see what we get. Right? So we have 1, right? It gave us 1, right?
Mm-hmm.
Because it's saying it's saying what it's saying is saying we have found a winning
Found a winning row.
yes, we have found a winning row, right? That's what it's saying. So like now if I change, let's change this, right? We can see that there is no winning row, right? So now we expect to get, wait, it still gave us 1. What did we do wrong? What did we do wrong?
I don't know.
Mm-mm. That means we didn't break at some point. So we have, let's test it out. Let's test it out. So we have previous one, right? Which is the value add row. Yeah, we have row 0, value 0, and that's the first value. So we have our 1 there, right? And then our current would be 0, right? Because we're still looking at, yeah, we're looking at that row. And then we compare these two, and then it says as previous is not, if current is not previous, break, right? Uh, me. That's fine actually. Then we break, and then we come back. We broke out of this loop, meaning the first row doesn't work for us, right? I'm actually just gonna print this out and just see what is wrong. So it actually just went on and did that. So we broke. Oh shit! I know why. I know why. I know why. You guys, can you guys see the problem? Huh?
No. I'm gonna guess it's
We're
line
not
10.
moving.
Huh?
Are we moving?
What do you mean? So the break, you know what break does, right? It breaks out of the loop, but it still continues to the to the function there, right?
I don't
Huh?
understand.
So when you do a break, right,
Mm,
it'll break out of this loop, right?
yeah,
But it still continues there and returns you 1.
yeah.
Yeah, so that's the problem. So how do we fix it?
Use continue.
How does continue help us though? So you want me to use continue there? I mean, it still gave us 1. Really doesn't change much. It's just that the only thing continue actually does, it just takes us longer to return the value, but we're going to return, it's going to do it 3 times now. Like, you could tell you,
Hey, Mana, we're not moving, though.
yeah, that's what I'm saying. But it's because we hit this return. So if I was, so we break, right? So we break out of the loop, and then, but I'll say, let's do this. Here's winner, right? I'll say winner. I'll just do this. Winner equals to true, right?
Oh,
Huh?
are we iterating here?
We are, yes. I'll show you now. I'll show you now. And then if that's that, we have our false, right? And then here I can just say if winner return previous, right? There. So we start off saying we assume we have a winner, right? In the beginning. We assume we have a winner. But then if ever we get to this case, our winner is false, right? We set our winner to false and we break out. So meaning now our winner is now false, and then it will come here after it breaks out of this loop, right? It will come here, and then if you still have a winner, it'll return that winner. Otherwise, it won't return anything. It will continue with the rest of the loop, right? Clear? Yes? No? Maybe?
Maybe.
Cool. So now it says none, right? Now we fixed it because we didn't have a winner. But if I was to change this here, my 1 there, now I get a 1 because we do have a winning row, right? Yeah. So now, so what we basically need to do, just a moment. So yeah. So do we are we fine with that? Huh?
Yeah.
Are we good? Now, how do we do the same thing for the columns? So I'll create the same thing. Compare files, and then we have our matrix there. What do we now do to compare the columns? I actually just showed you how we do it. A simpler way, or a simpler way we could use, right?
Yeah, that thing we just did, dog.
What? This one.
Yeah.
We could actually just do this, right? And then do that. If that makes sense.
Okay.
Does that make sense?
Yeah.
Okay, explain it.
We just change the matrix to columns and then you compare it with that function of comparing.
Yeah, because this matrix that we use here, right, is comparing the rows, right?
Mm-hmm.
And our zip function here basically just turns our columns into rows, right?
Yeah.
Mm.
Yeah, so we turn our columns into rows, and then on the since now our columns are rows, we can use uh, the compare rows thingy to get if there's a winner, right? Now, if I have a winning column, a winning is there?
This one.
Yeah. So if there's a winning column now, and then we do this, what are we doing here? What are we doing on data? Compare that. And we want to print it out. Okay. So we there. It gives us a 0, right? So now, Mr. Jack. So instead of doing all those comparisons, now you already actually have one function, right? That you can use, or two, depending how you want to do it, to compare your rows and your columns, right? So meaning you can actually, for the tic-tac-toe game, you can have you already have you already have functionality to check if there's a winner within columns with this code, if there's a winner within rows within this code. Now, I'm not going to do the diagonal ones, right? I'm gonna let you guys do it, uh, but I'm gonna push this one up so that you guys can have a look at it. I'm just gonna go add. Yeah, you guys can pull this code down now, but yeah. So this is what you can use to to check for a winner within a column and a winner within the rows, but you still need to check a winner within the columns. So that's what you guys still need to do. And we'll look at that tomorrow. Just a moment. Can you hear me?
Yes, we can.
Okay, cool. Yeah. So we good now? Any questions?
None so far.
Okay. So yeah, so how are you guys going to approach the columns one? I'm just interested. Not the columns one, the diagonal one.
In my head, I have a way of doing it one way,
Okay, let's hear it.
which is I have to index 0, 0, and then say within my for loop should go 1, 1, 2, 2, 3, 3, 4, 4, etc.
Okay.
But what is going to confuse me now is how am I going to do the other diagonal?
I mean, it's essentially the same thing.
Yeah, but there's something small that's different.
It's just the direction, right? Where you start. So where you start is different. So you start from
So how do I index the last row?
-1, right?
Oh, okay.
Yeah, because -1 is the last row, and then you're basically just
Subtracting.
yeah.
Subtracting for the row and then adding for the column.
Yeah. We'll see it tomorrow. It should be fine. But yeah, you already have the winning one from left to right. You just need to figure out the one from right to left. Cool. I'm gonna stop recording now.
Mhm.